Welcome, students. In this lesson, I would like to introduce you to physics. What is physics about? What are we here to study? Where should we begin? Let's find out. At male high school, we usually require people to take chemistry class before physics. So, do you remember how chemistry is defined? Well, one way we define that course is as the study of matter and the study of changes in matter. In a similar fashion, I think that you could legitimately define physics as the study of energy and changes in energy. Now, obviously, there are interactions between matter and energy because matter can't do anything without energy, but energy comes from matter in a lot of cases, like when you, say, set something on fire. So this may just be sort of a point of view, but I think it is an important distinction that our focus will be a lot more on energy and what it does to matter than on the reverse. So if we are going to define physics as the study of energy and changes in energy, it might be important to find out what energy is. What is energy? That's a really good question, and there is no really good answer. Energy is what energy is. It is a fundamental aspect of our universe. Instead of defining what energy is, what physicists most of the time do is they tell you what energy can do. So physicists say that energy is the capacity to do work, or the ability to perform work, or words along those lines. Now, that definition of energy is not too hard to remember, but what does it mean? Because if you want to understand this definition, you have to know what physicists mean by work. So if energy is the capacity to perform work, and I ask you to define work, how would you do that? Well, a physicist might define it differently than you. To a physicist, work is the result of a force moving an object. Work is the result of a force moving an object. So once again, we have a deceptively simple definition. So we need to know what a force is if we are going to understand what work is. What does the term force mean? Work is the result of a force moving an object. In fact, we actually have to understand two things. What is a force, and what does it mean to move? You can actually express work as an equation. It involves both force and movement. So we have to study motion. What does it mean to move? As that slide just illustrated, when something moves, it goes from one place to another. And it does that at a certain speed or velocity. It's a similar term. When you start at one spot and you end up at another spot, we call that displacement. So velocity is actually a calculation. It's the quotient of displacement divided by the time that it takes to complete that displacement. So we could have an equation, velocity equals displacement over time. So let's stop just for a moment and make a little flow chart here of what we've said so far. Physics is the study of energy. Energy is the capacity to perform work. Work is done whenever a force moves something, causes a motion. That motion has some components such as how fast does it go? What is its velocity? And in order to calculate velocity, we have to be able to measure displacement and time. So when an object goes a certain velocity, that means it has undergone a certain displacement in a certain amount of time. So one way to approach our study of physics might be to reverse this flow. What if we said, first we'll look at time, and then displacement. And from displacement and time, we can calculate velocities. Then we will know about motion. And we'll look at the causes of motion, which are forces. When forces move something a certain distance, that causes work and energy are going to be essentially equivalent concepts by the time we start looking at them in a few weeks. So what that flowchart demonstrated is that we might want to begin our look at physics by looking at time. But what is time? Do you know what time is? I want you to stop the video and I want you to type or write on a sheet of paper what your definition of time is. Please don't look it up. This is your own thoughts. You have experienced time. Have you ever thought about what it is? Take 2 minutes and write that down. Whatever you wrote as a definition for time is probably correct. Time is many things. We can think of it in terms of a clock and the seconds ticking away and the minutes and the hours. In the old days, maybe you would have measured time with an hourglass. And ultimately, you can think of time as being some sort of measurement that we make that is related to the spinning of the Earth and the Earth's passage around the sun. If you look up a definition of time, you may find something like this. This is what Wikipedia has to say. Time is the indefinite continued progress of existence and events that occur in apparently irreversible succession from the past through the present to the future. Time is a component quantity of various measurements used to sequence events, to compare the duration of events or the intervals between them, and to quantify rates of change of quantities in material reality or in the conscious experience. Time is often referred to as the fourth dimension, along with the 3 spatial dimensions. Now that definition is actually fairly complicated, and it does include a lot of elements. I'd like to look at some of those components in just a little more detail here. We'll start more or less in reverse. It said that time can be considered a fourth dimension along with the 3 spatial dimensions. So spatial, space, means up and down, back and forth, left and right, X, Y, Z axis in math class. So you can actually think of time as a fourth dimension. Another way to locate an object is not just where it is physically, but also where it is in terms of time. Now, there is a couple of really big differences between the spatial dimensions and time as a dimension. One of them was mentioned in the definition of time. Motion seems to be potentially reversible. If I go forward, I can go backwards. If I go sideways, I can go to the other side. But time is irreversible. We only move forward. But is it really irreversible? Because if I look at light from, let's say, our sun or a star, I am actually looking at that light as it was at a previous time. When you look at the sun, you are actually seeing what the sun looked like 8 minutes ago because it took time for that light to travel to your eyes. And interestingly, although we do move forward in time, we cannot see the future. We cannot see what anything will look like 8 minutes from now. So spatially, I can see in front of me, but in terms of time, I cannot. So what's the bottom line on this? We aren't going to really be able to get a really good definition of time. We're going to say that time is a factor that we can measure. It's something that we can quantify in a unit called seconds. Now you can gather those seconds up into minutes and hours and days and years and so forth if you want to, or you can split it into fractions of a second. But second is actually our unit of time. It's the way that we will measure whatever time is. If we can, we will come back and explore the nature of time later in the course. But for now, why don't we move on in our flowchart to the concept of displacement. So in our next lesson, we will take a little bit closer look at what displacement means. For now, I want you to take those writings that you made about what is time and just put them aside somewhere, but hold on to them. And maybe later in the course, you can pull those out and you can think about them in terms of what we have learned in the meantime. That's all for now.